Hello, welcome back to Sushi Live Nodding. In this episode, I want to share with you some kind of experiment that I'm doing with Spreadshop. Basically, I'm trying to understand how it works when a script like this is being run. This is actually a script that you can run when you have like a material and you kind of want to see all the connections into that material, things like image texture, and then showing the path. um, so this is what I did using Spreadshop add-on. So you start with a material and then you kind of filter out the material, and then you get all the nodes, and then you also can pick up one of the last nodes, which is normally the material output, and then you keep going, and then you kind of goes inside the inputs, and then you find the links, and finally you get to the nodes itself, like maybe like showing the name or showing even the texture. So it's a little bit difficult to explain, but I got this script from Blender Stack Exchange, and these two are really helpful. um, so the question is it possible to find the nodes connected to a node? It's kind of like when you see like a node tree, it's looking like a tree, and then you kind of going into the root, and you want to get into every single branch. That's a that kind of listing is actually kind of pretty hard to do. So I'm gonna show you the blend file, so you can just download it from here. So I wrote here with Python, traversing tree recursively is easier than nodes. It is actually kind of true, unless the nodes itself is kind of doing recursive thing. So let's just open it up. Let's have a look. This is a cube with a simple cycle material, and this material normally, like the most basic one, probably you'll be using Principal BSDF with a metallic and roughness plug into some kind of files, and maybe you also have the normal, but in this case we only have image texture plug into the base color and the metallic, right? And if you imagine like a tree, this is like the root of the tree, this is the last node for the material, which is material output, and you will have a lot of branch. You can have surface shader, volume shader. In this case we only have a surface shader, so surface, something plug into the surface, which is in this case the Principal BSDF, and you can have a lot of textures and something that's definitely more complex. A friend of mine that's using Houdini told me that in Houdini you can look at everything as a nodes, and then you can think of it like a file folder. Like in this case I have downloads, and in here I have another folder with a lot of files. This is actually really interesting, and I kind of understand the concept, but sometimes it's really hard for me. But this script down here is not that complicated. This one is the functions that select a nodes, and then it's kind of give you all the list of other nodes that's connected into these nodes, and then it goes into this one and then do the same thing, and then this one and do the same thing. So if you, in this case, okay, if I just run this script a couple of times, you will see in the output it's actually running the script a couple of times. So it says traversing the material, starting at the material output, and then material output, there is something plugged into it called Principal BSDF node, and then there's also image texture, and so there are two image textures from Principal BSDF. So this is really helpful, even though it's not like digging really deep. So I try to visualize it using nodes because it's a lot easier this way. Although you also want to use this command line, this Python Python console, and you can get into the material this way. So let's try doing this first. dpy data. So I think I go to the materials, and we have something. We have this material node, and from this material nodes we can list all the nodes, I believe. So we get into the node tree, and then we can list all the nodes this way. So this is a list of all nodes under this material. For item in list of all nodes, print item. So we can see we have principal VSDF, image texture, and material output. Only 4 nodes. This is a very basic nodes. By knowing this list, of course we can get into this node and then perhaps print out the path into the image. So that's really helpful, right? Because very often you want to do that using script, and there's definitely add-on out there that's kind of doing this, and the idea is to understand it. Here I'm using nodes. I'm doing the same thing like what I'm doing here. Get all the nodes in the scene, get data materials, filter it out by name. The name is called material, and then get inside the node tree, get all the nodes. So we are up to here. So we can see all the nodes, and then we filter out the nodes. We want to select the material output. I believe we can also get the type here, the type of the node. That's another thing. That's the type of the node. Text image. The type of the node is kind of specific per node, but you can either use the type and filter out the type, or you can also filter by the name. In this case, I'm just using the name, I believe. So material output, that's the name of this guy. You can label it, that's another thing. So once you're on that node, you can actually go into inputs and the links, and doing all this, get the name of the nodes, for example. In this case, I'm looking at only input number 0, which is of course the surface, and then get the links number 0, and then the links number 0 is this guy right here. I think I'm gonna try, what I'm gonna do is to try to dig inside one of these nodes. So that now I'm inside principal PSDF, and then I will do the same thing, input links and from nodes, plug this there. Hopefully I get what I'm trying to get. Principal PS input shader node, and we get, of course, image texture. So that's what's plugged into this guy. Let's see if I can get something from links 1. So nothing. Link number 2, 3, 4, 5, 6. Well, that's probably not the right way to do it. Maybe I should look at it from the inputs. Maybe it's the input. It's the input number. One, 2, 3, 4, 5. Maybe number 5 or number 4. So input number 4 is of course image texture 001. So I couldn't find anything. Yeah, because what's plugged into this node is input 0 and input number 4. Of course, in this case, it's the base color and the metallic. So yeah, from there you can perhaps look into the name. Let's try and dig deeper. So from this node, you go deeper and then see if we can get something out of this. Okay, ppy.data nodes image texture inputs. Okay, let me fix this first with Sverchok. Maybe kind of enlarge the scale by 2 times and then save, and then we open this. So now the input is properly showing. The output of stethoscope is properly showing on the right. Okay, so now it's a bit cleaner. So input 0, is this input 0? Maybe this is input 0. So what is this exactly? This is the name. This is probably like a special attribute of image texture. So we need to get into this path somehow. So let's try go to the desktop and then just use any of this image. bpy.ops image open directory files. So let me check what is this. Is not an input. This is like just an image. Properties. So this property. This is a bpy data image file path. So it's from these nodes that's image texture. We need we don't have anything on the input 0. If we have something, we're gonna have let's say if we are using like a procedural texture coordinate, and we use the normal, then we can get to that nodes this way. So bpy.data.nodes texture coordinates. So that's correct, because we don't have image. Oh, okay, we have, because this node itself has a way to access this file path. Let's try actually doing that. We need to go back to the nodes. Okay, let me check. Image texture, bpy image texture node file path. So that's how I'll search it. Changing the image in the image texture using Python. So that's usually the answer. You get the answer there from scripts. This one is saying material slot. This is probably using the old Blender. Or there's this image. Okay, let's try. So we get to the image texture and we are looking at the inputs. Maybe we can look at the image. There we go. There we get to the image, and then once we get into the image, we can dig inside the file path, and there you go. That's the file path. So that's how you get into the file path of material nodes. Slightly more complicated using nodes, but you can see with SphereChalk and this object ID nodes, you can really dig deep into the nodes, kind of going into the branch and maybe find the leaves of a node tree. Although the difficult part is when you have multiple items and you need to kind of recursively go deeper. That's when scripting is easier, probably easier. Yeah, so that's kind of proving a point, right? Like this is looking into a material nodes like this, but with everything can be visualized using SphereChalk add-on. This is where I found it's really, really powerful, because you can also do this kind of thing using for a folder in your directory. That's probably I'll try to do that next time, but for now, this is like a material node, and then looking at it like a tree, and you can use Python and then kind of traverse into the nodes, goes into the branches this way, but you can also use nodes. So there you go. Hopefully you find this useful. Let me know what you think, and I'll see you next time. Thank you. Bye.